Welcome to another video on my channel. Today's video will be on the function Modulus. It is a well-known function and we know that this function always gives a positive value whether we put a negative or a positive value. Okay, so we have this function y equals to mod x. Now this function has this property. It will be x if x is greater or equals to 0 and it is minus x if x is less than 0. So what does it do for positive values like 2, 3, half, these, it gives the exact same value. However, for the negative values, it gives minus x. So from here we can see that if x is less than 0, in that case minus x will be greater than 0. So this part, whatever this value the function gives, it will be always 0 or positive. Okay. So for the x greater or equals to 0 part, it has some structure, and for x less than 0 part, it has some other structure. That's why it is called a piecewise function. Now, for the positive quadrant part, we have this y equals to x. So it is straight line. Again, for the negative quadrant, which is x less than 0, we have this minus x part, which is again a straight line. So first, let us understand how to draw a straight line. So suppose we have this straight line here, y equals to mx plus c. What does this m do? This m is the slope of the straight line. As I have already discussed in the identity function video, please check out that video to understand how does the straight line works and how do we plot its graph. So this m is the slope of the straight line. So that means if the straight line makes an angle theta, then with respect to x-axis, then this m will be tan theta. And what does this c do? This c is the y-intercept. So that means, so let me write it down. So if this makes an angle theta, then m will be tan theta, and this part here, this is the y-intercept and that will be the c. Now, we had two straight lines. One was y equals to x and another one was y equals to minus x. So, for y equals to x, we have what? We have, if we compare it with this, then we get that m equals to 1 and c equals to 0. So, as the m equals to 1, from here we get that theta equals to 45 degree, as tan 45 degree is 1. So, it must make an angle 45 degree with respect to the positive x-axis, and it must cut the y-axis at 0. Okay. So, we have, for this part, we have this straight line. Let me draw it. So, suppose this is x-axis, this is y-axis, then this straight line which passes through 0, 0 will be y equals to x. Okay. Now, for the negative part, which is this y equals to, okay, so it should be minus x. So, this is y equals to minus x. So, for y equals to minus x, what we have? We have m equals to minus 1. So, m equals to minus 1 means theta equals to 135 degree. Okay. And here again, if we compare it with that general form, which is y equals to mx plus c, we get that c equals to 0. So, again it should pass through the 0, 0 point. Now, if we try to plot this line y equals to minus x, we will get it must make an angle of 135 degree with respect to the positive x-axis. So, it must go like this. Okay. So, this function is y equals to minus x. Now, if we go back to the original function, which is y equals to mod x function, what we get? We get y equals to x at the positive part. So we need to take only the positive part from the y equals to x, and for negative part we have y equals to minus x. So we only need to take the negative part from the y equals to minus x graph. So here the positive part is this part, and here the negative part is this part. So by combining these two, we get the y equals to mod x graph, which is this one. So this is y equals to mod x graph. This part, this right hand side part is y equals to x, and this left hand side part is y equals to minus x. This one is x axis, this one is y axis. Okay. So we have plotted this function y equals to mod x. Now, moving to its properties, firstly, we can see that it is a piecewise function. It is obvious from the definition of this function. Next is that the domain of this function is R and range of this function is 0 to infinity. So, I have already mentioned it. So, we can put any value in the input, but what we will get in the output will always be either 0 or positive. So, this must be the range of this function. Next, it is decreasing in minus to infinity to 0 and increasing in 0 to infinity. So, if we try to calculate the derivative in two different parts, what we will get? Let us see. So, for x greater than 0 part, we have y equals to x. So, in this case, the derivative is y dash, it will be 1 greater than 0. That means it is increasing. And for the x less than 0 part, what we have? Y equals to minus x. So, if we try to do the derivative will give y dash equals to minus 1. This one is negative, so it must be decreasing. Okay. Next, it is an even function. So, for even function, what we do? We try to prove it. So, f of minus x. Again, for the mod x function, whatever mod x is, mod of minus x will be always the same. So, whether we put mod 2 or mod of minus 2, it will always give the positive value. In this case, it will be same. So, it is an even function. Next, it is continuous in R. So, from the graph, it is obvious that it is continuous in R. So, we can continuously draw it without taking off our pen. So, if we try to prove it, so for continuity, we need to consider three cases. One is when C belongs to 0 to infinity, that is C is a point in the positive part. For that, we have limit x tends to C fx. So, x tends to C. C is in the positive part. So, the function must be x tends to C mod x. So, here the function must be x, as we are considering the positive quadrant, positive part of the x axis. So, it must be C, and as C lies in this 0 to infinity part, f of C will be equals to the same value. So, here we can write it as mod C. So, it is f of C. Next, when C lies in the minus infinity 0 part, we have limit x tends to C fx. Again, if we put the value, limit x tends to C mod x. Now, as we are considering the negative part, we must have mod x as minus x. So, it has the value limit x tends to C minus x. So, it will be minus C. So, as C lies in minus infinity to 0, so minus C is the positive value. So, it is actually this. So, this is f of C. Again, so for C positive c and negative c, we have already proven that this function is continuous. Now for c equals to 0, we need to consider both left hand side limit, right hand side limit and the value at f at c. So here we have limit x tends to 0 plus, so we are considering c, so in spite of writing it as c, we are writing it as 0. So we have fx, so I'm writing not fx, I can write it as mod x. So as we are considering the 0 plus part, that is the positive part, it will give limit x tends to 0 plus x, and we can put it 0. So similar thing occurs for limit x tends to 0 minus, we put here mod x, but as it is 0 minus, it is less than 0, so we must have minus x, that means 0, and we already know that f of 0 equals to 0. So these two are equals, that means the limit exists and the limiting value is equal to this f of 0. So this function fx is continuous throughout the whole interval r. Next, it is differentiable in r minus 0. So it is very important. This function is differentiable, everyone. We can prove it by, so we can see it here. Here, this function is differentiable. Only problem is at this point x equals to 0. As we can draw here multiple tangents, as we don't have unique tangent at x equals to 0, this function is not differentiable at x equals to 0. So if we try to prove it, so let us do it. What happens? Let us see. So suppose we consider the point x equals to 0. So limit x tends to 0, fx minus f of 0 divided by x minus 0. So we must have f of 0 is 0, limit x tends to 0, fx by x, and we have the fx function as limit x tends to 0, mod x by x. Now the problem is that if we try to take 0 plus limit and 0 minus limit, those two will give two different values. So for 0 plus limit, we will have x by x, so it will be 1. But this is not equals to minus 1, which we will get from the 0 minus limit. Limit x tends to 0 minus will give this. Okay, so this value here, it becomes 1 when x is greater than 0, and this becomes minus 1 when x less than 0, and at x equals to 0 it is not even defined. So this function is not differentiable at x equals to 0, but it is differentiable at any other point. So for the positive value, we know that if we try to do the derivative, we will get f dash x as 1, and if we try to do the derivative in the negative side, we will get the derivative as minus 1. Also, it has a minima at x equals to 0. So it is again obvious from the graph, as the graph of this function has this kind of structure. So it has, this is decreasing. Okay, so from the infinity, if we try to go from minus infinity to 0 towards 0, it decreases. So it has here, for this part, it has the minimum value at x equals to 0. But after this, when we go from 0 to plus infinity, this value increases. So again, if we try to go from 0 to infinity, this point again has the minimum value. So it must have the minimum value at x equals to 0, but we cannot show it by using the derivative, as this function is not differentiable at x equals to 0. Thank you for watching this video. Please like and comment on this video, share this video with others, and subscribe to my YouTube channel. In the next videos, we will discuss other piecewise functions like signum function, box x function, and so on. Thank you.